All right, gang, this is the last section of Chapter 1. What we're going to be talking about is referred to as linear regression or regression analysis. And there's different types of regression. If you have a quadratic, you could do quadratic regression. You can do regression on any type of function. And what it is you use your calculator to determine the line of best fit for whatever data that you have. So you probably do this a lot in your science classes. Whenever you have a set of data and you're trying to figure out what the pattern is, you do a regression analysis and it tells you the equation for the data. When you get into statistics class, you're actually going to determine how to come up with that equation, which is somewhat involved, takes a little bit of work. But for right now, we're going to use our calculators to do that. And it's pretty simple. No head math at all. So what you're going to do, and to those of you who don't have the TI, I apologize. I don't know how to work every calculator that there is. But that's what we're going to be looking at, the TI, which is probably what you're borrowing for this class if you didn't have one anyways. So first thing we have to do is enter the data into lists. And to get to lists, you have to hit the Stat button, and then the screen that comes up, enter on Edit. And you're going to get columns like this. And you can see that the columns here are L1, L2, L3. List 1, List 2, List 3. And by default, the program, when you do a regression analysis, by default, it always uses List 1 and List 2. There's a way around that, but it's probably best if you just try to keep your data in L1 and L2 all the time. Sometimes it's not possible, though. So enter your X data in L1 and enter your Y data in L2. Now, after you've done that, it's important that you quit this screen so that you can go back to the main screen. Otherwise, everything you enter is going to be in that list as opposed to where you actually want it. So now you're going to quit so that you get to the main screen. All right, once you're back to the main menu, you're going to have to go back into Stat again, and then you're going to click on Calculate this time. Because now the data is entered, now we want to do the actual linear regression. And what's going to come up on your screen is this. And that fourth one down, you can see that number 4 says LinReg AX plus B. That's the one that we want to highlight. So you scroll down to that and you hit Enter. And when you do that, your screen is just going to say LinReg. And if you're only using L1 and L2, then you just hit Enter and it gives you the equation. All right, so this is what it looks like. You've got LinReg on top all by itself. You hit Enter, it goes through the calculation, and it gives you all those different values right there. Like I said, by default it chooses L1 and L2. If you wanted to use L3 and L4, say, then after you hit LinReg, you would enter L3, L4. Okay, and the lists are above the numbers on your keypad on there. All right, so you hit Enter and you get those values there. You may not have the R and the R squared. You have to set your diagnostics on if you want that. And those do have a meaning for us. Right now, we're not all that concerned with what it means. In statistics class, you will be concerned. So if you have R and R squared, fine, but we're just going to ignore that for right now. All right, so I want you to follow all of those steps with the following set of data. And double check to make sure you entered all of these correctly. So pause it and enter this stuff. All right. So now we're going to actually go through and make the linear regression equation using the steps that you just did. And that would result in this equation. Your A is 0.212, your B is negative 0.309. So that's the equation for the set of data that we just entered into that list. Now, the fact that we're ignoring the R squared and R right now, makes it imperative that we actually look to see how well the data is represented. We used a linear regression, so we need to look at it and decide, okay, is this actually linear data? Oh yeah, this data is actually the number of cricket chirps as a function of temperature. Yes. All right, so just that last thing, let's take a look at the data in a scatter plot to see if there's a good linear relationship. So to do that, you have to hit the stat plot, which is above the y equals button. And that's the menu that comes up there. And really all we want on is the first one. The rest of them we don't need. So you're going to highlight number 1 on there and hit enter. And then you get this screen right here. So what you want to do is make sure that that is on and make sure that it's using L1 and L2. All right, so what this is going to end up doing for us is giving us a graph, what the graph looks like. However, we need to make sure that we have a proper window. If all the data is right here and your window is way over here, then you're not going to see anything. So we have to make sure that we get that right. So now you're going to click on that window button and put in a reasonable range for our data there. And I would say use 60 to 100 for your X's, going by 10s. Use 0 to 25 for your Y's, going by 5s. All right, so you're going to enter all those in the following fashion. Your X min is 60, your X max is 100, and your scale is by 10. Then go ahead and do the same with your Y values. All right, the X RES, I never even worry about that. Quite frankly, I have no idea what it means. Okay, so in case you're wondering where the 60, the 100, the 0 to 25 came from, I didn't just make them up out of thin air. They came from our data. This was our set of data, and if you look at L1, we had a low of 69.7 and a high of 93.3, so I said we'll go from 60 to 100. And that was a fan that fell over. Yes, I do have fans. No, it was actually a spinning fan. Okay, in L2, we had a low of 14.4 and a high of 20. That's a pretty small gap. So I would just make it from 0 to 25 to make it inclusive of everything. And then as far as the scale goes, you know, just kind of use your head. How many? All right, so that's where that information came from. And when you do it, and you hit the graph button in the upper right-hand corner, you should see this data like this. And if you look at that, it does look like it's linear. It looks like it has a really shallow slope. And if I remember right, the equation was 0.212 for your slope. So 2/10 up 2 over 10. That looks about right. So the equation that we came up with using the regression represents that data. That is how you use the linear regression. And to that I say,